Hey everyone, thank you so much for joining us today for the first session here. We're privileged to have a couple of amazing speakers, and just a quick introduction here, and then we're going to get going. So it's my pleasure to introduce Miss Emma Qian. She's the co-founder and chief executive officer of Nova Intelligence, a cutting-edge technology company transforming how enterprises modernize complex legacy software systems with AI-driven solutions. Emma's a dynamic leader at the intersection of artificial intelligence and enterprise technology. A graduate in computer science from Caltech, she began her career in foundational AI research and development, including roles at Google DeepMind and other leading AI ventures, where she helped shape the early practical applications of intelligent systems. A fun fact about Emma is she won first prize at the largest university-level data science competition in the world, competed against winners from 24 regional competitions held across North America, Europe, and Asia. She's agreed to join us and share some of her brilliance. Please join me in welcoming Miss Emma Qian. We also have Mr. Justin Kershaw. So I'm introduced to introduce Justin as the Chief Customer Officer of Nova Intelligence, where he plays a pivotal role in championing customer success and guiding enterprise partnerships as organizations harness next-generation AI. Justin's a seasoned technology executive in a number of roles, including Chief Information Officer and Corporate Vice President at Cargill, one of the world's largest privately held corporations. Justin's broad leadership, combined with his passion for enabling organizations to solve the toughest challenges through technology, make him a compelling and insightful speaker. Please join me in welcoming Justin Kershaw.
Okay. Welcome to everybody online as well. So hopefully you can hear a little better now. Thank you again for being here. And as Emma took us through, we're going to talk a little bit about SAP, but we're going to talk a whole lot about Nova and SAP, and we're going to talk a whole lot about Agentic. And I have to be honest, I started as an advisor to Nova, and I started as a incredibly skeptical advisor, and that there's no way any of this agentic stuff can be true, certainly not with a solution like SAP, which I lived with for years, and many CIOs like myself have, and the intractable problems that come with a solution. But let's get real here. 85% of the Fortune 500 run SAP. That's 425 out of 500. It's kind of pretty much everybody, right? 70 plus, almost 80% of the business transactions in the world are running through that environment too. So what's that really tell us? It tells us we're dealing with a really, really important problem and a really important issue that are on assets in the biggest companies in the world and transacting the business of the world. Oh, sorry about that. So what are some of those intractable problems? Well, we took those assets on and we started to modify them. And we've been doing that for years and years. SAP's 300 million lines of code. Pretty much everybody that bought SAP thought they had the few lines of code that it didn't have and was necessary for their company. And usually they figured that out before they ever even used it. And they decided to, put all that code into SAP, and maybe they used it after go live, maybe they didn't. But what we know is it's lived there for 20 plus years. And that is what we call the intractable problem, adding to the total cost of ownership, and a problem we don't often mention out loud, but the risk that is associated with that asset. And that risk in the last 20 or 30 years hasn't gotten smaller. It's gotten exponentially larger, particularly in the last few years. I'm not going to stand up and here and tell you about the hacks that have happened to SAP, either in my day, having to run it as a CIO, but even in the last year, which was a popular year to hack SAP. But I'm going to tell you, we all know that's a risk. And what can Agentic do? What can these agents do to help us get through all of that? The average transformation to get from your existing version up to your new one is anywhere from 30 to 300 million. That's a lot of money. That doesn't make the people that have to operate that real popular when they go to say what's high on their list or what you're going to talk to the board about or your executive team about. We heard a little bit about that from Neil just on architecture alone earlier this morning. We know the custom code is, very costly to maintain, and that, like leading up to the year 2000, so you may not have been around then, there's a shrinking pool of people that really know how to do it. That pool of people that really know how to manage these issues and get through them, despite their costs, is not growing, but it's shrinking. So what do we do? Oh, sorry. So what's changed? Agentic and AI is changing that landscape. And it's giving us solutions and options to handle those intractable problems like never before. And what you're going to hear from Emma is, what are the principles behind how to go about that, and what is possible. And having seen it work, I turned from a significant skeptic who was a part-time advisor to a full-time employee because, as weird as it is, if I wasn't a CIO, I would have implemented ERPs all around the world because it's what I did from the beginning of my career and had a heck of a lot of fun doing it. And that led to where I am today. But I love the work. I love the importance of it. You all are involved in it, as is pretty much everyone here in this conference. And we're going to talk about some things that are going to change the landscape of that. So, Emma?
All right, thank you, Justin. So yeah, for setting the context. So with that, we're going to go into more of a section around, just talking about what are AI agents, what are they capable of, and then transition back to how specifically we are leveraging these capabilities and Nova to be able to solve, this particular problem around SAP as well. So, yeah, so we're going to go through a couple of these topics. Right? So what is agentic AI? How do you design for them? What are some, sort of things we've seen from our experience on how to bring to the organization? And then also, finally, how are we able to create agentic AI agents that actually work for, SAP in this case? But maybe more broadly, how can you create AI agents that work for different use cases? So, yeah, so one thing that I want to start with is just, there's a lot of talk about do AI agents actually work? Is it just all hype? Can they actually solve any real problems, etc.? So, of course, we as an AI company strongly believe this, but I think there's also pretty strong evidence out there that AI agents are already quite capable and also becoming more and more capable really rapidly. Right. So one example that I want to share is that there's a competition called International Math Olympiad, which is really the highest level of math competition in the world. And in the recent months, right, both Google DeepMind and OpenAI, as well as a smaller company called Harmonic that's focusing on AI for math, have been able to create AI agent systems that's capable of winning the gold medal at essentially this the most prestigious, the highest level math competition in the world. And this is sort of just one of many things that AI has accomplished that's extremely impressive, that even a year ago I think even experts wouldn't have believed that it's possible, right? But of course this is not the case, like, as you look around on what are AI agents you're encountering and using, it doesn't feel like this is the level of intelligence of every AI agents that you are currently leveraging, right? And I think there's multiple reasons. One is that there's an interesting phenomenon that these AI agents are, particularly can be surprisingly good at certain tasks and maybe less good than you expect on other tasks. So it's not like uniformly distributed intelligence across everything that humans are currently doing. However, they are, at a base level already getting very intelligent, right? So examples like this is solving novel math problems. It's clearly not pattern matching or anything. So how are agents able to do that at all? And how do you design for an agent system that can accomplish things like this, right? So the first principle that we believe in is, we should design AI agents as if they can actually think through complex problems and are able to solve complex problems. And what does that mean in practice? So if you don't believe, for example, that AI agents are capable and that they can, reason and solve problems, you may end up in a situation where you're designing very rigid workflows, for example, not letting the agents go experiments and plan and actually iterate on these tasks, right? So, and this is actually something that we've been seeing as these AI agents, like AI models and AI agents get more capable. We ourselves at our company have been deleting more and more code around our own platform, right? So in the past, we did need to cover a smaller surface area, have it be more like constrained, and not tackle everything out there, and therefore the capability is a little bit more limited. And as AI models get smarter, I think one thing that we've noticed across the board is it's actually like people are deleting more and more of the code that are used to build these systems, and now the AI model itself is able to come up with tools that as it's planning, able to sort of come up with hypotheses and plans for these different use cases, right? Able to get quite far on its own. You don't need to handhold it as much in a lot of use cases. And what does it take to actually build an AI agent system, right? So I think there's a few sort of critical pieces. One is very clearly defining what is the goal that you're trying to accomplish. And if there is a way to verify whether you actually achieve the goal or not, that's even better. And I think that's the traits of, we look at, for example, the math problem, right? The one nice thing there is you could verify, is the solution correct or not? Also with code, right? A lot of times you can also create your own tests and be able to verify, does it pass the tests that either humans created or the AIs come up with? And if there's an objective way of checking whether you achieve the goal or not, then what happens is these AI agents are able to iterate right towards the right solution and able to be a lot more autonomous, because you don't need humans to come in every time to verify did it work or not. It's able to get there on its own. Maybe it stumbles a little bit, but that's okay, right? It's like what humans do as well. It's not like the best programmer will never need to debug anything or never write a wrong line of code. They do. They just are able to recover from the mistakes quickly. And then the second area is planning, right? And I think this is becoming more and more important as AI agents are taking on longer and longer running tasks. So you wouldn't expect, for example, that a programmer working on a complex problem would be able to just in one step write every line of the code correctly, exactly on first try. You probably break down the problem into smaller pieces, iteratively get there, right? Break it down into maybe 10 steps that might depend on each other. So similar thing with AI agents, and it's able to do that pretty well now, is planning through a more complex task. The third area that I think really distinguishes an AI agent from something like a chatbot or just a model is the fact that we give these AI agents tools to interact with its environment, right? So, and this ties into something we'll talk about a little bit later, but it's very different thing to like just think about what is the right thing and come up with a thesis versus being able to leverage tools to test the work that you created, be able to use tools, for example, in the coding example, right? If we could give the agents tools to like look up documentation or do Google search or, be able to search across the code base effectively, you can imagine how that makes a person much more effective, and it will make an AI agent much more effective as well. And final thing is, AI agents are able to, much like humans, able to reflect on its own work and come up with, what is the right thing to do next? Did I actually do the work correctly? Come up with tests, for example, or be able to execute those as well. And yeah, this is sort of what we alluded to a little bit earlier, which is for any complex problem, you can't really like just sit there and think and come up with the right solution at the end. I think one good analogy is like, what would a human need to be able to solve complex problems? And it's intuitive why that's the case for humans, right? So you have to interact with the environment. And I also want to show this graph from this is an organization called Meter. So especially if we give AI agents the ability to do the 4 things mentioned earlier, we're seeing really astonishing rate of improvements for these models, right? So if you look at this curve, and it's an exponential curve, and even with some of the recent models, it's continued on this trend, right? These AI agents are able to work on tasks that are going to take humans longer and longer. So with like GPT-5, Grok 4, etc. Now they're able to solve problems on its own that would have taken humans like on the order of 1 or 2 hours to do, right? And in the more extreme examples, like sometimes these models can work independently for 7 hours or 30 hours. Of course, these are outliers, but you can see the trend of going towards more and more autonomy. And human oversight is very important, but these models are becoming quite capable, so we'll need less and less sort of like kind of micromanaging and more that you could hand off a task and just come in and verify at the end. And this is sort of I think one of the most important ways to create a higher performing agents is giving it the right tools to interact with the world. So you can think, for example, for our case, when we're building coding agents, right? Humans have had many decades now of building these developer tools that make human programmers much more effective. We're still at pretty early stages of building these developer tools for agents, right? But imagine like someone who has no like developer tool as a programmer, someone who has all the modern development tools, the effectiveness of those people is very big, right? And this is sort of similar analogy for agents as well. And one thing I want to definitely touch on is evals. There's multiple reasons, but one thing is, building AI agent systems is actually, I think it's really different than anything we've seen before, where just the speed of change and improvement is just so quick. Even in the last month, I would say, right, with Claude Opus 4.5 and some like GPT 5.2, for example, the recent models that came out, people are continuously being pretty shocked by how fast the models are improving compared to November of last year, which is really a month and a half ago. There's now a giant leap in capability again. So the capabilities are changing extremely quickly. New models, best practices, techniques, all of that are all constantly changing. So how do you keep up in a world where things are moving so quickly that before you finish building something, maybe the next wave already came out? And how do you continuously make sure to improve? I think the most important thing is building evals, which are essentially test cases about what the model should be able to do. All right, so with a given, in this particular scenario, for example, the model should be able to, in our case, be able to generate documentation that contains these critical elements, or these are the types of custom code that the model should be able to create, right? So generating almost like a list of test cases that you can continuously evaluate your system on is more critical than ever, especially given how many new things you could try. And this is, with AI agents as well, everything that you tweak, like you change a prompt or you change a technique, it can have downstream effects that are very unexpected, right? So maybe you, without evals, you can imagine that maybe there's a particular use case that you're able to solve for now, but then it actually made a bunch of other performance worse. And it's really hard to catch those unless you have a way to continuously evaluate the AI capabilities, right? And this is sort of like a similar concept to why you might want to have just test cases for normal software as well. Yeah, and then the other principle that I want to mention is just I don't think like we're at like we shouldn't think of it as AI agents are now running everything at the company. They're making decisions for you. I think humans at the end are accountable for what these AI agents are doing, right? So like AI can help you get to the solution much faster, but someone should be like over reviewing the solution and making sure that it's actually the right thing to do. And partially it's because humans have a lot of like context that these AI, it's just not possible to hand to the AI, and also it's not like we shouldn't be trusting the AI to make critical decisions or anything. So therefore, it's important to design these AI systems so that it's easy for humans to interact with them, understand what did the AI agent do, and is it the right thing to do, be able to correct and provide feedback to the AI agents, right? And usually starting sort of smaller and then expanding as confidence grows. I think one good analogy is can someone on your team who is currently doing this, domain expert, etc., would they be able to come in and work with a very capable junior member? That's like kind of the way that we think about AI agents. It's someone who's smart, hardworking, very fast, but someone who doesn't have like all of the contacts you have. It doesn't have like the domain knowledge that you have. Okay, I know we're coming up on time a little bit, so I'm gonna skip through a couple slides, and maybe talk mostly. Oh, we have time? Okay. Great. So then I'll come back to this slide. So talking about how do we think about agentic AI in an organization, right? So I think productivity is a clear metric that agentic AI can increase. But beyond productivity, the benefits are, being able to make decisions quicker, which typically means being able to like run your business much better as well. The quality improvements, as I think, is a big one that people are surprised by. Is that these AI agents are able to create a lot of time with the right setup, right? Very high quality like outputs as well. Making the employees happier because they're able to do less of the repetitive work, and enabling the organization to do things that wasn't possible before. And yeah, thinking about upskilling, right? So I think one thing that is very clear that is domain experts and people who have the context of the organization and the field, they're going to become more valuable, not less, in the age of having more access to intelligence systems like AI agents. And I think one skill set that's going to become more and more important is how do you work with AI agents, and it's a little bit like delegating to junior team members, but not exactly, right? So, and it's certainly I think we've seen a big difference in people who are able to work very effectively with AI systems, and people who are not able to do that. So I think it is a skill set that requires practice and some training to be able to do that very well. And yeah, of course, like I think it's good for people generally in the organization to have some level of understanding of what AI agents are like, what AI is able to do. So I think a few common sort of pitfalls that we've seen, right? So it's one is like probably only solving for technology. I think it's important to tie like what is the AI system you're bringing to the organization solving for in terms of business problem, and also change management, right? I think like bringing a solution like this into an organization can have an impact on how the teams work. I think skipping evals is a big problem that we've seen because it's not like fun to have to come up with extensive list of essentially tests for the AI system. But if you don't start with that, I think it's very easy to end up spending way more time on these systems and performance degrades pretty quickly. And the final one is, something that we've seen quite commonly, which is, like building your architecture in a way that's too rigid or too tied to the capabilities today. I think it's important to be very flexible, just given how fast things are changing in this world. I think it's for AI in general, AI is not accountable for the decisions that you're making. So it's important to have some human reviewing and approving anything that the AI is doing, especially before it hits production. Right? Okay, so maybe talking a little bit about now, how are we building AI agents for SAP? And maybe just a time check on how much more time we have. Oh, 20 minutes. Okay, great. Yeah. Okay, great. Yeah. So, that was maybe more of a presentation on what are AI agents in general, how do we think about it, and now we could go more into how are we building AI agents for SAP, and then go into questions after that. Yeah, so one thing that I want to talk about a little bit is, why we even decided to build this in the first place, and why we think this is a valuable platform, right? And the main reason is generic AI coding tools work a lot of times poorly for domain-specific tasks, and including for SAP, right? And that's the area that we chose to go after. But I think this is pretty broadly applicable as well, that a lot of times, for a lot of use cases, AI agents in general, or generic AI agents, might be able to be very helpful. But for some more domain-specific tasks, you may need specialized harnesses and engineering around it. So one area, right, is that we've built in a lot of context and knowledge into our AI agent system on more domain-specific knowledge about SAP, right? And this is something that the general systems don't have as much intuition on, especially given how fast the rules are changing. So we make sure that our systems always have up-to-date information about the latest information and rules around SAP. So AI models in general do have some general understanding of a lot of information in the world. One thing that they don't do as well is that if things have changed a lot, or if things are updating very quickly, right? I think it's important to ensure that we always have the right, most up-to-date context. And I think the more important part is that, for SAP, for example, to what we mentioned earlier, it's for an agent to be able to iterate towards the right solution on especially more complex or longer running tasks. It's important to let them be able to interact with the world and be able to verify its own outputs, right? And this is, I think, one of the main areas that we built for, which is that we built our AI agent system to connect to your SAP system so that it could now interact with the SAP system, be able to check, did I build something that even compiles correctly, and can I run a unit test to see is the result correct or not? And this is how we're able to iterate towards the right solution, right? So because we have that feedback loop with our agent system, now it's able to look at the outputs from, for example, SAP and say like, oh, did I, is this correct? And if not, let me go back and try a different route. And in this whole feedback loop, the humans don't need to be there every step of the way, right? So you can assign agent a task and it will go and try like 10 different things. And maybe on the 10th try, it's able to get it correctly. But on the first try, it was incorrect. That's very common. So that's why it's important to create this sort of feedback loop for these tasks. Yeah, this is one thing that, of course, ChatGPT out of the box is not connected to your SAP system, doesn't understand how to interact with it or like write into it, right? Like, so this is one of the biggest differences between us and generic coding agents. And yeah, so a few things that we do differently at Nova compared to normal just AI agents. Being able to directly connect to the SAP systems, as we just mentioned, and being able to keep the state across different steps, right? So the agent knows like, these are the things I've tried and it didn't work for this reason, or this is the error that I got. So let me take that information and think about what is the next best thing to try and be able to come back with a reasonable suggestion, right? So having all the context of the things that you've tried before and using that to come up with the next best suggestion to continue to iterate on it would be, is another big difference. and we bake in SAP's like latest best practices and information into our system. So part of our system is also keeping track of all of that information, right? So that's another big difference. And yeah, and as a result, we're able to close this loop of being able to plan for a task, be able to build it and check, does it work or not? If it doesn't, then go back to planning on what can we try next, and then keep tracking that, right? And because of that, our agents can now run over a much longer time horizon and be able to get much closer towards the right solution in these complex tasks. And very briefly on the different use cases that we are sort of tackling here. So one is documentation. So this is where our agents are able to go in, pull in knowledge from different parts of your SAP system, right? And this is not a one-step thing. So going back to how we design these systems is a lot of times the agent will pull in some information given a task. It will look at the code snippet and say like, okay, so I know that there's a few things referenced here that I need to understand for me to completely understand the functionality. So let me now retrieve these other information as well from the SAP system. So a lot of times this is a multi-step workflow, even on the documentation side. And after each step, the agent will reflect and think about what other information do I need, or what else do I need to know to create the thorough documentation. And yeah, fit to standard is similar, where we can run fit to standard analysis, which means checking what you have currently and suggesting, is there anything from SAP standard that you could replace it with? And again, this is also a multi-step workflow, right? A lot of times we do this sort of research, compare what you have against SAP standard, but then there's an additional question that the agent might have about, well, is this part really related, or is this, like just sound like they're related, but not really, right? So then they will do a further research step and then dig a little bit deeper into the information there. So for all of these workflows, I think, being able to iterate through multiple steps and being able to, the agent itself being able to pull in for more information and be able to, like kind of think through the right way to do this makes a huge difference compared to something that's like just a question and then one answer immediately. And on the build side, which is our coding agents, right, where we're able to write code and modernize code, that's where the plan, build, verify loop is particularly important. Be able to verify, does the code work or not, through things like both checking the syntax compile, but also, can we create unit tests and check if the functionality makes sense or not, right? That's where, like being able to kind of verify and replan makes a huge difference to that part. Usually the first attempt at these coding, like the coding agent makes is incorrect in some way, but letting the agent being able to iterate much closer towards the right solution without a human always in the way, and it makes it so that it can create a huge amount of productivity gain for the user. And I'll very briefly mention maybe just on the right-hand side here. So we're backed by SAP, et cetera, more on the company. But I think the more interesting thing is on the right-hand side here, where I want to talk a little bit more about why, like the difference that a good agent system makes compared to the model. So our company actually started as a general coding agent company. We did not specialize in SAP originally, so that was a pivot. And originally we built a general coding agent framework that was actually able to 10x the performance of the underlying model, right? So our AI agent system is built on off-the-shelf models. At the time, it was GPT-4. GPT-4 on its own at the time was able to get about 2% on the something called Sweetbench, which is the most popular AI coding benchmark. And even though our coding agent system was built on top of the model and we didn't have our own proprietary model, the fact that we had this agent system that's able to plan and test things and iterate, right? Leveraging the intelligence of the models means that it's able to now solve 10x more problems on this benchmark. And there were other players at the time that were taking a similar approach of building agent systems on top of the most capable models. Just wanted to highlight that there's a huge difference like between using just ChatGPT or Claude, the model itself, versus building an agent system on top, specialized for a particular problem that's able to iterate through multiple steps and get towards the right solution. Okay, so with that, I think that's the end of the presentation that we have prepared for today. And yeah, maybe I'll take any questions that people might have in the audience, and then I think there's some people online as well that we can go to. Go ahead, yeah. Yeah. Yep. Yeah. Mhm. Yeah. Yeah. Yeah, that's a great question. Yeah, so that's like one of the biggest questions we think about because like it's just these AI capabilities changing so quickly that actually it really does feel like every month or sometimes maybe at most 2 months there's a huge shift in capability, and now a lot of things we built before doesn't make as much sense. We don't need as much guardrails, or like the best practices for how to prompt these agents or interact with the agents have changed, right? So that's why like evals is one of the biggest topics that we focus on at the company. We spend a huge amount of time curating our own set of evals. And you can think of them almost as just like a list of test cases, right? So for each of our capabilities around, for example, documentation or fit to standard or modernizing code or building code, we have an extensive list of scenarios of around these use cases, right? So here's, for example, a document. What is the right fit to standard sort of outcome for that particular scenario, right? Or here's someone's like design document for a new capability they want to build. Can we actually build out the capability? So we have a very long list, extensive list of these evals, which helps us iterate quickly. So you imagine that as a new model come out, right? So we will evaluate on our system and see what the performance is, and maybe we try a few new techniques and see how that changes our performance. I think that's the most important thing in the face of extremely fast change in sort of AI capabilities, is to have some way to objectively measure what is the performance of my current AI system, and be able to measure that quickly, right? So a lot of times people start with, if you don't have evals, the way that people do this is just by trying the system, right? You'll change the model and then you're like, I'll run out a couple cases, use cases, and then see what the outcome is and see if it makes sense or not. That's a few problems with that. One is it's like if you want to run it on the long list of use cases, it's super time intensive, right? And given how fast things are changing, like we're often changing things like pretty significantly every week, right? So given how fast things are changing, if you're manually essentially running all of these tests, it's just extremely slow, and there's no way that you could keep up with the the actual pace of progress, right? And of course, second issue is that it's hard to be comprehensive when you're just manually testing things and getting a gut feel of how well the system works. Like maybe you tried a couple scenarios and it does work better, but there's a bunch of other things that you didn't try and the performance actually degraded there. And we see that all the time. When we make a change, maybe the performance increases in one area, but it decreases in the other area, right? So designing some sort of system, and that also goes into the design of evals as well. Like what is the overall score? So we always recommend like having actually like one score that you optimize towards, right? So how do you calculate that score? What is the breakdown of the different tasks you're testing for? So yeah, so that's a very long answer to basically, like, I think what boils it down is having evals that you reliably, like, that you can run periodically to check the performance of your systems. So yeah. Okay. Yeah. I don't know who was it. Yeah. Yeah. Mhm. Yeah. Yeah. Yeah, no, that's a great question. That's a great question. Yeah. So two things. One is that we do have this like fit to standard capability. And what we found a lot of the time is you have this custom code, but you don't even need it because SAP has something that you can use out of the box, right? So and it's very common because if you have decades of code built up, it's pretty likely that there's a lot of areas you can reduce. But the second part is, even if your capability cannot be fit to standard, right? To your question on like, do you even need it? like two things we can check for. One is like, is this code even run at all? So you can look at the usage, right? And if there's hasn't been used in like a year, you probably don't need it. The second area is, it's interesting that you asked about do you talk to business users and get the capabilities, right? So we are spending a lot of we have one of the biggest, I would say, like benefits of our platform is that almost like this knowledge capture of understanding what is your SAP system doing, and then also augmenting it with, sort of documents from the company. And we're actually pushing out a new feature very soon of like AI interviews with people at your company, right? So the agents with understanding of what is your system actually doing, the usage, all of that can now come up with intelligent questions of like, and think through like, is this actually needed, or what are you actually doing here? What is your goal, right? And be able to augment these knowledge, into our overall system as well. And that we definitely think that's one of the areas where AI can make a huge difference as well, is like understanding what is the underlying reason for this to exist in the first place. Do you need it? And is there a better way to do it in the future? So, okay. Yeah.
I mean, that was a brilliant question, because that's one of the big ones we live with, right? We always have a longer list of modification requests than we can actually do, and this can help you really do it. And I just want to maybe end on one thing. I took 2 notes during Neil's, scribbled them on the back of my page here, right? Managing complexity is a cost, right? You're architects, right? And what I'm going to ask you to do is take the fight to your leadership. Like, get to know Agentic. Challenge your organization to get to know what this technology is capable of. Not everybody's going to get it right away. And like everything, right? I've been around a long time, 40 years in the career. Mostly in the beginning, when the new things are coming, we're afraid of them, right? So help them get over that hump. Be the one with the knowledge. Like, use the lessons Neil gave us. Managing complexity is a cost, and then guiding trade-offs. I have 100 mod requests. I got money for 10, right? That's a trade-off. The architect needs to be, you got to have your nose in the fight for that. And you got to be heard, right? And get to know this agentic technology, take Nova, get Nova on board if you're running SAP, and help your monolith get healthier. Right? It'll change the architectural nature of your organization, and it'll help manage the risk, right? And start to help your organization understand the risk of what that complexity is and the cost of it. Because I'm standing here and I can tell you, right, that cyber insurance, it's not going to help you when you're hacked, right? Like, having lived through many of these, right? And any CIO who tells you they don't take it personal, fire them, right? Because it is personal, right? And the cost to actually get back, it's not stopping the hack, it's the cost to get back. Simplify your environment, because the security risk is coming, and it's coming right into your face. And I'm looking in, I know a lot of you people in the room, and I know your organizations deal with massive risk. So I know I'm overplaying that a little bit, but I'm just saying this is what made me a believer, and I'm challenging you as architects, like, spread the word, get your organizations adopting this type of technology, even if it's not us, right? But if you're running SAP, you should really take a look at that. All right.
Emma, Justin, thank you guys so much. Can we have a big round of applause? A lot of great information, a lot of lessons learned. The best lessons learned are the lessons we don't have to learn. We learn through you guys. So thank you all so much. We're going to get set up for the next session. If you have questions for these folks, please find them throughout the conference. I've talked to both of them. They have so much to share, and they're willing to share their knowledge. So please reach out, and we'll talk to you in about 10 minutes here. Thank you.